Hello there, ladies and gentlemen, and welcome to the world of Autodesk Inventor. Comment down in the description below. I know some of you are coming from different CAD software. If you're coming from Fusion, SolidWorks, AutoCAD, I know AutoCAD users also around here. Welcome to this YouTube channel where we are going to be learning a lot of stuff to do with Inventor. Inventor is one of the products by Autodesk that is mostly used when it comes to product design. Different CAD softwares have different uses, but Inventor is mostly used for doing such things. When it comes to construction and all of those stuff, you have different tools that we are going to look in later videos or later episodes on what they do. Whatever you are seeing there on your screen, that was a project which I did some times back, but for this tutorial we're not going to be doing this, so you can relax. Doing something like this, as we go along the way, you will realize that it's not anything rocket science. This was a wheel loader that I designed. When the time I was doing this, it was done in SolidWorks, but I decided to do it all the way, interpreting SolidWorks to Inventor, making each of the components that has multiple components. Here, if I turn around, you can see it very well, but let me also change the view here to the perspective so that you have a more of a realistic view of how it looks. You see, when I click and start dragging these, you can see how the bucket moves, how the boom and the hydraulic arms, the rocker arms, how they are kind of interacting with one another so that you get this kind of movement. So today I just wanted to show you that, but that is not what we are going to do. This is going to be a beginner's guide, step by step, on how you can get started with Inventor. So the first time when you open up Inventor, this is how it usually looks like, and this is, like, we can call it the landing page. So once we are here, most of the time, like, this is the preview window of the things which I was doing before opening it up. This is like the home page, how it looks like. Once you are here, most of the time you want to create a part, you click on new, and this window usually pops up. Most of the time here, when it comes to designing things in Inventor, it's a bit different from when you're doing it in AutoCAD, but when it comes to other softwares, it's usually like the same thing. In Inventor, you start by developing a component, which is an IPT. Component is a path, is like a part. Like, for instance, you have your phone. Your phone has the casing, has the screen, has all those different components. So your screen, for instance, that's a part, an IPT file. Now, when you have modeled all those parts, you open an assembly environment where now you put all of your components together. You constrain them. If there is motion, a certain motion that you want to assign, you do that in an assembly environment. Going down, we have these the drawing environment is where now you generate your 2D views, like the front view of your product that you're making, the side, and all of those stuff. Most of the time you can see the DWG, that's the AutoCAD version, because there's a relationship between Inventor and AutoCAD, because first of all they are from the same family. So you create your 2D design. So you open a different file if you want now to create something that is going to be fabricated or made somewhere that is under the drawing part. And then when it comes to your presentation is where now you want to animate, show how it moves and all of those. Although that one you can also do it in the assembly environment, but for presentation you have the standard IPN or the standard millimeter. That's where you create your presentation from. So we are going to look at as we go along, because it's going to be a series of videos. But for this one I wanted us to open the path. So click on the standard millimeter IPT. Depending, most of the time I like working in the metric, but you can work with any. So under the part you have the sheet metal. Going to look at the din.ipt, the standard millimeter IPT. I prefer the standard, so click create there, and what it will do, it will open for you this blank canvas where now you can start developing or designing whatever that you want. So for the new users, where I'm hovering the cursor here, we call it the canvas, and this is the browser window. All the things that you do, they are displayed on the side here, and on top here is the ribbon. So each ribbon, it's under a particular tab. Like for instance, all of these features that you see here, they are under the 3D model tab. If you click on sketch, you have a different icons, annotate, different things, inspect, tools, manage, view, and so on and so forth. But for this tutorial, we are going to do some of the basics of sketching. I know, let's say you are coming from AutoCAD, majority of the things that you do there are mostly in terms of sketching and everything. Now, to start a sketch in Inventor, when you open up, the first icon under the 3D model is Start 2D Sketch. Click on that, and you're presented with these planes here. You have the XY plane. You can see when I hover the cursor, it turns greenish to show you that's the XY. You can also look at the triad here. XY means that it's on this plane. We have this one, which is the XZ plane, XZ plane. We have the YZ as well. I prefer using the XY plane because before I came even to Inventor, I was using AutoCAD before. I prefer doing most of it on the XY plane. So click on the XY plane, and now it switches. You can see we have switched from the 3D model now to the sketching environment. And Inventor, when you switch to a different environment, all the other, like most of the time, the other tabs are usually disabled. Like you can see now, all these others are grayed out. They annotate here, you can see they're also grayed out, and other tabs. Now, in the sketch environment, there are so many things. We have the line command, the circle, the arc, the rectangular, and when you click the drop down arrow there, you can see different things that you can do, like you can create your splines and all of those stuff. As well as the circle, we have different things, like you have the center point circle, the tangent circle, where you have different lines and all of those stuff. Same to rectangular, the arc, yeah. So if you have it installed, you can explore what you can do. Even fillet, we have fillet and chamfer here. The text, when you click down, you can see all of those stuff. So we are going to explore step by step each tool. It is going to be like the CAD tips and tricks to to make your work easier and to make you settled when it comes to inventor. Now let's start with line here. Line, you see it's just a line. If I click here and start dragging the cursor around, moving around, you can see we have a line here. You can click as you move like that, like that, like that. So that is your line command tool, and once you are done, you right click and then you can click OK. Yeah, see now we have a line here. And most of the time, let's say if you are coming from AutoCAD, you will find that for you to configure things to the way you want, you usually use these commands like the move, the copy, and all of those stuff. But here in Inventor, you will find that things are a bit different. We mostly work with constraints, yeah, to align. Most of the time you will find yourself not really using these tools a lot, but you will be using the constraints, these tools that you have here to bring to maintain the design intent of whatever that you are trying to do. For instance, we have this line and this line. If let's say you want this and this to be, let's say this and this line, you want them to be perpendicular. You have this perpendicular tool here. So if you click this as your reference and this, you see it's 90. If we come to dimension here and look at the angle here, you can see it's 90 degrees there. Yeah. Let's say you want, now you see these and this, you want now to make them parallel. You have the parallel tool. Click parallel, click this as the first one, and then that second one. Now the two will be parallel to one another. You can do this with this as well. You see there, this with this, they're also parallel. Yeah, you can do so many things. That is the parallel tool and the perpendicular constraint. And the good thing about Inventor, when you hover over an icon, it gives you that window where that preview, you can read what it does, like the parallel causes selected linear geometry to lie parallel to each other. That's the parallel tool. Yeah. So we have looked at the parallel as well as the perpendicular. Then let us look at the coincident constraint. Coincident constraint, what it does is that you select a point as your reference where you want to move a particular point to, and then you select. This is what it means. I like demonstrating by, if I zoom in, to zoom in and zoom out, what you do is when you scroll away from yourself, that is, you are zooming out, then to zoom in, you scroll the wheel towards yourself, okay, the mouse wheel. Now let's say I want this point here to be coincident with that, so you click this point to be coincident with that. You see now it brings that here. You don't need to use move to bring that point there. I think that is self-explanatory. Yeah, that is what the coincident constraint does. All right, let's say we had another line like that. Click OK. We want to move this point to this, so we could use again coincident. Select that point, then that. See, it moves it there. Okay. Now the other thing, if your part has been constrained, no matter what you do, if let's say you try to drag these, click and click as you drag out, yeah, left click as you drag out, you see it's always attached to this point. Yeah, it can never move because there is that command. Even if you move it around, it's always attached to that end point there. Okay. All right, let's look at the other thing. We have these we have the collinear command. What it does, it from mathematics, is that it makes a line parallel as well as in line with a particular line. This is what it means. Let's say we have an arbitrary line here. Click OK. we have that line. We want this line to be collinear with this. Select collinear, select this as your reference, and then select that. See, now we have this line, they are now kind of following each other. So this was the first line, and then this was the second, where if you click that, you can see where it ends, it terminates at this point there. That is collinear. And then we have the concentric command. Let me delete everything. To delete, select and then hit delete on your keyboard, and then it will erase everything. And then before even we proceed, let me undo that. Yeah, now when you start your sketching, there's usually this point here. If I hover the cursor there, you can see it turns greenish. Now that is usually the reference point. Let me erase this. That is usually the reference point. Let's say the reference point, you always want your part to always be referenced to this part. That is the best practice. I'm also going to make another video on the best practices when it comes to Inventor. For instance, if you are making a rectangle, select rectangle, you want the center point of your rectangle to always be on that point. If I hover the cursor, you can see it turns to a circular dot. If you click there and drag out, you have your rectangle there. Now with this rectangle, the other thing about Inventor is that when you are sketching, it's like you are just drawing without dimensions in mind. Dimensions, you come now, you put them right along. Now this side, now you can assign it. Let's say you want it to be 50, type 50 there, and then that is the length, and then the width you can make it 20, and then enter. Yeah, now once you put these dimensions here, you can even come back right along and change them, and then they will update themselves automatically. So to change, double click, and then you can put there 80, then click enter. Double click on this other side, you can also change that to 40, enter. Yeah. Now the other thing I would like to show you is that in Inventor, you deal with, most of the time, it's not more of a parametric design, but you see here, when you assign a dimension, that's a parameter, like the argument. 80 is an argument. Now when you are putting these, the best practice is always, you can always label them, like what does 80 stand for. So you can double click on that dimension, and you can type in that width equals to 80, click enter. And then on this side here, you can also double click and say height equals to 20. Okay, now that is assigning those parameters. Now these parameters that we have entered, like by labeling that 80 is equal to width is equals to 80, you can come here on this fx, that is the parameter tool there, and that's where these parameters are usually stored, like that list of everything in your sketch environment. They are stored under the parameter tools. You can even modify from the parameter aspect. I'm waiting for it to load. Sometimes it becomes a bit sluggish, my PC. All right. That's about the parameters. Yeah, you will be presented with this window. If I minimize a bit, you will see this window. Sometimes it's usually scaring to the users, but It's nothing rocket science. You see, we typed width, it's here, and then height. You can see width here is 80, this was this side, and then the height is 20. Okay, you can even modify from this parameter here. You can even say that you don't want that to be 80, you want it to be 70, and then when you click enter, on the side here you can see it has updated itself. Those are the parameters. And then yeah, you can also do the same with the height. And then once you are done, you can explore about the parameter tool, what it does there. All right, the other thing I wanted to show you is that here we have this dimension property. You can also okay, the thing I did there, let me repeat this. Click on this dimension there, and then right click on it, and then there is this dimension property here, and then click on that, and then this pops up here. You can see the name there, as well as this is the precision. I don't want to go into details for that. Yeah, but you can also modify from there. All right, okay, let's continue to now to a different tool. We have the concentric here. For concentric, most of the time you need an arc or a circle for that command. So click on circle. Let's say we have one circle there, and let's make another circle here at the bottom here. Concentric, what it does, it puts the center points of the two circles coincident to one another. This is what it means. So coincident, if I select this first circle and then the second one, you can see okay, let me undo that. So that, because these circles seem to be of the same side, let's make another circle here that is smaller, so that you see what it means. Click on coincident, select this, then this as your second. See now that the second circle has been moved into the first, and their center points, they are attached to one another. So if you click and drag, you see you can expand, you can enlarge the smaller circle, but the center point, you click the center point and you start dragging, you see the two circles, they move along. And then the other thing I would like also to say here is that in Inventor, you can see here this rectangle here has a different color. It's all white, and this is purple. Is that purple? Okay, whatever it is. But this one that is in purple, it means that it's not fully constrained, it's not fully grounded. Because when you click at this center point, you see you can move it around anywhere that you want on the window. And most of the time you always want to make sure that your sketch is fully grounded. If I click at this center point of this rectangle, if I try to drag around, it can never move from that. It's fully constrained. That is why it is white in color. Even when I click on this side, I try to move it. I click, you move, it doesn't move. Okay? You always want to make sure that everything is fully constrained. This is not fully constrained because one, it doesn't have dimensions. You don't know how big is this circle. Can click there and then double click to put that. We can say this is 50. Enter, and then the outside one we can double click on it. Then we can say this. We can even give it a name. We can call it outer circle. Outer circle equals to 90, and then when you are naming this, you can see everything here is in red, meaning that it will give you an error You are not supposed to use space. Everything's supposed to be together, or you can use an underscore or anything, but to be one. Okay, so if you put a space there, then you click enter, it will give you this error here, this warning. The expression cannot be evaluated. Okay, so you make sure that there is no space between these parameters. There is no space there. Okay, and when you go to your parameter tool there, you can see the outer circle has been added there. Okay, and then the other thing I wanted to also show you is that, let's say for instance you want this inner circle to always drive the outer circle. Yeah, sometimes you want that to happen, like one parameter, if it changes, it affects the other. Because if, let's say this one, the inner circle is right now is 50, if we expand it, let's say to 60, it expands but nothing happens to the outer circle. To do that, what you can double click on this and then click on the inner circle there, and then you can always put there anything, let's say plus 20. What that means is that you want the outer circle to be the size of the inner circle plus an increment of 20. Okay, so if we click OK there, you can see now the inner circle is 60, then we have added 20 to make it 80. Okay, so if, let's say, we change the size of the inner circle to be, let's say, 30, you see the outside also changes. Yeah, so the inner circle parameter is driving the size of the outer, yeah, of the outer circle. That's really useful. There are so many things. Let's say if you are making a pipe, the inner diameter is varying, but you want the inner diameter to vary with the outer diameter. Okay, so that's really handy. There are so many things that you can do with that, but I hope you get the point. Now you see, now we have assigned, but our sketch can still move around. Yeah, you can see you can still drag it around, but we can kill this movement by putting, let's say, a coincident constraint. We want the center point to be constrained to that, so we can even click here and click that. See, now it moves it to that point. Now your sketch is white, is fully constrained, fully grounded. Anything, if you try to drag it around, you cannot move it. Okay, and it's not just with this point. If, let's say, I undo that, you can even make it coincident to this point here. So anything depending on what you want to do to that point, you can see it's now constrained to that. All right, that was concentric, and let me also show you another tool here. Let's say if we had a line like that, then there is this icon here that is called fix. What fix does is that it grounds a particular thing, or even if it's a line or an arc, to the position that it is currently. By clicking fix, now if I try to drag this line here, I cannot move it because it's fixed at that position. Away from fix, we have looked at the parallel and also the perpendicular. Let's look at the horizontal constraint. All right, let's make a line like this. Click OK. We want this. You see, this line is not horizontal. Horizontal, it's with respect to this. It's with respect to this plane, that is this line, this thing that you see here. So if you click horizontal and then you click on that line, you see now it is like parallel to this plane that is at the bottom here. The same thing with vertical. Let's say you have a line like that, and then you click vertical. What it will do, it will make inventor will do it will make sure that this thing is as straight as possible. So that is the vertical constraint. And then we have the tangent constraint here. The tangent, from, I think you have heard this from your mathematics, is that it makes a point on a circle, it attaches the point on a circle to a point on the line. Like the line will touch this circle at one point. So tangent, click this and then you click this. You see now, if you can drag, but I think that, yeah, that is still tangent. If we expand this one here, we can still expand. Now we can see this line is tangent. Even the way it was still before that was still tangent. The only problem was that it didn't have. And if you drag this, you see you can drag it around, but this the reason why it's not cooperating very well. Let's say we put here to be 30, enter, it's still tangent. That is the tangent tool. Let me erase everything here, click delete. By deleting, there's a problem here. The problem is now we don't have our reference point here. I did that knowing because sometimes you encounter these issues and then you don't know what to do. Because if you try to draw a line and you hover cursor here, you see it doesn't turn greenish, yeah, doesn't, because it doesn't have a point where it snaps to. Okay, now if you encounter that problem, you can undo, but what I like doing is that if that happens, you see you have your browser here, you have the name of the part, which is part 3 because we have not saved it, and then you have this is the view representation. We're going to look at view reps later on, but when you come to origin here and you expand, okay, you expand here, you have different planes. You have the YZ, the XY. When you hover, you can see there's a preview on your canvas. It turns greenish. You have the XY. That's where we are doing the sketch. Now there's this tool that is here that is called project geometry. If you click project geometry and then you click that point here, you see it will project that dot. You see now we have our dot back here. Initially it was not there. Yeah. Now if we come to draw a line there, we can see it snaps at that point. Yeah. That is what the project geometry does. What it does is like cast the shadow of that point to whatever that we are trying to make here. Okay. All right. As I had said earlier on about these tools, most of the time you rarely use them, but I swear they are really useful. Like the circular. Let's just move step by step. The move is there in AutoCAD, self-explanatory. So you select the geometry that you want to move. This one. You can either make a copy. If let's say you want a copy, you can click on copy and then you select the base point. You can use the end point here, and then you see you're free to move it. You can even now attach it to that point there. What it will do now, you see you have the original as well as now the copied version of this one. And then once you are done, click OK. That is the move. Copy does the same thing. So copy, you select the geometry and then you select the base point. You can click now here and then you can move it there, and then once you're done, click done, or you can just cancel. Okay. Copy, you see copy does yeah. copy it makes a duplicate of the original version. And then we have the trim tool. Let's say we had a line going there like that, click OK. The trim, it cuts geometry. Select trim there. What trim tool does is that it removes geometry to another line. Like you see where they are intersecting here, it will erase all of this and leave to the point where they are attached. So you can also trim these, you can trim that, you can even trim that. So trim, it not only trims but it also deletes. Yeah, you can do that. You see, you have deleted so many things here. Okay, and then we have our point here. And then scaling, it's self-explanatory. Extend, let's say you have a line like this, okay, and another line like that. So if you want to extend, you see it extends that to the second line. You must have another line. Let's try to see, let's say if we didn't have another line, if that really work to extend. So it extend now here, it will extend it to infinity here. All right, that is the extend. The stretch, you can hover the cursor there and you see what it does. So if you click stretch, select the geometry and you want to select the point that you want to stretch, and then if you start dragging, the geometry being edited is constrained to the other geometry. Yeah, so if something doesn't work in Inventor, it will give you this warning that it cannot do that, because right now it's agreeing to do that, but it was initially constrained. But yeah, if something that doesn't work but that was agreed to work, I think you get the point there. All right, let's delete everything there, and then circulate makes up. Let's say we have a circle here, small circle there. Let's give it a dimension of, double click, let's say 10 there, enter. 10 is really small, let's make it bigger, let's say 30. Okay, now we want the center point of this circle to be aligned, to be in the same line with the center point, with this point here. So for that, there are so many things you can do. You can use the vertical constraint, and what it will do, it make that, see, it aligns, it makes this point vertical to that. And then you can put a dimension, how far from the center point you want that to be. You want that to be, let's say not 30, but let's say 49. Okay, now once you have done that, you can see your sketch turns white. It's fully constrained, you cannot drag it anywhere. Now let's say we want to make copies around this point here. You can use the circular array, so it will array your geometry, it will make copies around a particular axis. So you select the geometry, you want that, and then select the axis. You pick an axis, click there, then by default it gives you 6 copies. You can vary this to 8. You see, now you have 8 identical copies. And then you around an angle, right now it's 360, you can change this even to 180. See, now you have 8 copies at an angle of 180 degrees. Yeah, let's return that to 360 like that. And then when you expand down here, you can make them, you can either suppress, but I don't like doing that. And then there are these tools, associative and fitted. Okay, if we disable fitted, you can see now we have only one circle. And then if we disable associative, what that will mean is that it will make these ones, it will make these 6 copies, but now each of them is different from the first one. Okay, once we are done with that, we can close the drop down and click OK. Now here we have 6 circles, not 6 but 8 circles which are independent. See, now you can drag it outside like that. There's no connection between these. So if we undo that and then we go back to that command and select the geometry like that, and then we select our axis to be this point here, and we want, let's say, 8 like before. We expand that and check the associativity on, and then click OK. You can see now these circles, all of them they are all associated. They have all the similar properties in terms of the size. All of them, they are 30, they have a diameter of 30, as well as they are equidistant from the center point here. If, let's say, I try dragging out, I cannot drag it because all of them, they are all associative. So that is the associativity property. And then we have the rotate. Rotate, it's self-explanatory, like we have a line there. And then let's say we want to rotate that, we select the geometry, and then you select the center point where you want to do the rotation. You can click this end point here. Now you see you can rotate it like that. Okay, alternatively you can put an angle. You see here it keeps on changing. You can say, let's say 90, and then click apply, then down. You see it has rotated that. Then split. So for split tool, select split. I rarely use the split, but for the split, most of the time it requires you to have a point. You see this the point here. Now the point, you can put it at the midpoint there. When you select split, it's not working, but split, it just cuts the, maybe you need to select and then you select split. I don't know why it's not working, but anyway, let's go to offset. But most of the time we will rarely use the split tool here. Offset, click that. Offset, what it does, it makes a copy at a distance, at distance away from the first instance. Like the first instance was this line. Now we can offset, we can make another copy at, let's say, 20 millimeters away, and then it maintains the property like they are still parallel to one another. So you have this indication. This indicates that the two are parallel and all of those stuff. All right. What else can we look at? Then the other tool is there was this one which I have not shown you. Let's erase everything. Click, select, delete. To delete this, select, then you right click, and then you want to delete. You can delete constraints. Then once you have deleted the constraints, then you're free to delete. Why is it not deleting? Okay, but that's no problem. We can go to a different part here. These are the other parts which I had opened before. All right, let me show you what the symmetry does. What the symmetry? If you hover the cursor there, you can see constrain selected lines or curves to be symmetrical about selected points. Yeah, symmetrical about. Select two objects to be constrained symmetrically, then select the line about which they are symmetrical. Or symmetry, what it does, it's like creating a mirror. So we can create our reference line, select the line here, and we want this line to be a construction line. So for you to turn it to a construction line, click here where you have the construction, and then now you can click the center point here, then you drag it out. See that line is dotted, that's a construction line. And then you can come make another line like this, still another construction, but to disable this, let's delete this line. Come select line again, but this line you don't want it to be a construction line. So to disable that, come click again. Now you see this option is deselected. Make another line like that and click OK. Alright, and then this line we can even assign dimensions to it. Let's say we want to be 20 millimeters like that, and parallel with this one, parallel like that, and we put let's put an horizontal constraint. We want this and this to be horizontal, and then the distance between here to be 10. Okay, and then if we create another line, arbitrary line like that, then we click OK, and then select symmetrical here, select this as our first line, then this as our second, and then this as our reference. You see now they are symmetrical in the sense that if you measure the distance in between, it's 10-10. The distance in between is 10-10. So it's like a mirror, though not really a mirroring, because you see the height is different. What symmetry does, it makes it like, for instance, they are still parallel to one another, but the distance away, the separation distance, it's equal. Okay, so if you drag this one, although this one you can still make it any distance you want, yeah, it's short. Let's say now you want to make it equal to the other one, there's an equal tool, so click equal, click this as your first line, and then this as your second. Now you see the two are equal. If you come to measure, see they are 20-20. Okay, that's about the equal tool. Today the concern was mostly about how to sketch and everything. You need to know how to sketch before you do anything like now extrusion and everything. Once you have your feet wet, you can now, you need to understand this, because for you to make anything else, let's say like a square tube, let's delete this. A sketch is the basis, is the foundation of anything. So, yeah, once you have your foundation for the sketch, then making anything else, it's very easy. Yeah, this is what I mean. Let's say we were to make a square tube, and we want this side to be 20. You type 20, and then to put the other dimension, click tab, and then you can put there 20. Okay, now you can see our sketch is full. We didn't have to, because of the best practices, it even saves you work. We put our center point, we selected as our center point as this point, and then now by changing things, yeah, by putting the dimensions, we didn't need now to put the things like the coincident constraint. Yeah, well, it saves you time sometimes. Yeah, all right. Before I proceed, there's something I showed you. Let's say we want to make a cube. Yeah, a cube. You see, this is 2D, two-dimensional geometry, and these parameters I showed you something about the parameters here. It's always good to name them if you are going to require them later on in your design tool to use those parameters elsewhere. So double click this and you can call, let's say, length equals to 20. Click OK. And then this one, double click it, you can call it width equals to also, you can even click this, you see, width equals to length. By clicking that, I don't need to type again if I want the things, so it will make them. Okay, and then once you are done, you can click finish. And then once you are finished here, I want you now to observe where the magic is about parametric design. If I click extrude tool, we're not really going to go deep about what these tools, because our major concern was majorly with the sketch command and all of those stuff. I want you to observe something here. For us to make this cuboid, we needed to have a sketch first of all, because whatever you are seeing extruded here, it had these, it had the edges for us to make this. So the sketch is always the foundation of everything. If you don't have a sketch, you cannot perform these other commands. All right, now the extrude tool, what it does, it makes geometry, it makes a solid out of the existing profile. The profile was a square. Right now, by doing so, we have these. So the extrude command, first of all, you need to have a profile. See, profile, it knew automatically what we wanted to create. And then the sketch plane, you don't need it. But here we have, you can either extrude it towards this direction, or you can change the direction to the other side. If you click, it extrudes to the other side of the sketch. And then you can have mid between. The default dimension there was 10. So from this plane here, it has stretched this side 5 millimeters, the other side 5 millimeters. And then we have this asymmetric. You can make this side here to be, let's say, 20. You see, that's bigger, and the other side you can make it 10. See, now that's the asymmetric constraint. That's what it does. You can even flip the direction. The 20 goes the other side and 10 comes to the other side. Okay, see, if we go to symmetric here, there are those parameters that we assigned, those parameters like the width that we created. If we want now to be a cuboid, there's this arrow here. You can click that arrow and then click this list parameters. Now you see the parameters we created, length and width. Now we can assign the height with width. You see, now if you click OK, you have your cuboid there. Okay, nice. See how cool that is. Now anytime, let's say we had the parameters here, let me minimize this, or let me drag it like this. Let me drag this. Let's say now we want to vary the length here to be 10. Click enter. See, it changes, it becomes smaller. And then that is the power of parametric design. If we make it 40, see, now it's bigger, and everything is all linked together. You see, our length was linked with the width, and then the width was linked with the height. That's the beauty of parametric design. And then the other cool thing about Inventor is that sometimes, you see, we have performed our first command here, which is the extrude command. We can even come here and we can you see we can extend this plus icon here, and then there was the initial sketch that we created here. We can click on the sketch, and then there's this icon, that's three icons that are presented here. The first one is edit sketch. If we click edit sketch here, we can even edit this sketch here, and let's make this 80. Click enter. You see everything updated itself from here. If we click finish, everything updates itself automatically. All right, this is the beauty of parametric design. And then let's do something else. But let's say you sometimes what else can I show you? Now once we have it like this, you can perform other things like doing the filleting, the chamfering. You can do the filleting there. You select this as our first edge. There you can see it makes those edges round. So we are going to look at the other tools, what they do, but what I wanted you to get from this tutorial is the power of sketching. And it's always a good practice, and then once you are done, click OK. And then you see here we have this fillet. Okay, the browser keeps on expanding and so on and so forth. This fillet, you can even come again, double click on them, you can edit them. You can make these even 20. That's really big, and you see what it does. It makes that kind of looks nice. You can keep on exploring. You can go forward, and then you update, you change things. All right. Okay, I think that is it for this tutorial. I wanted you guys, mostly for the beginners, to understand what these things does, especially when it comes to sketching, because sketching is the basis for everything. It's the basis. It's for you. You cannot okay, this is what I mean. If you don't have a sketch, you cannot do anything. And to prove the point, what I mean here, we have these. These are the activities that we have done here. Let's move back. Let's move everything back. You see, there's this end of path. If we drag this upwards, you see everything that we have done gets suppressed. Now this is our starting point here. We don't have anything. If I click on home, you see there's nothing on our canvas. If we try to extrude here, if we try to do extrusion, we cannot perform that if we don't have a sketch. So if you click extrude, it brings you these planes here, meaning that you have to sketch first. Okay. If we click revolve, the same thing. Instead of giving you an error, I think the other versions, because right now I'm using Inventor 2022, the other versions, they used to give you a warning. But with this one, I'm also going to do a video on the new things the new things in Inventor version 2022, because this one, it never used to be there in the previous version. If we click fillet, you see could not bend. Select the component, has no volume. The selected component has no volume. You need to have something for you to do all these other things, and that you need to have a sketch and a solid that you want to do the things. Now Because we dragged everything behind, that means we did not delete anything, yeah, but the browser, we can return everything back to normal. Yeah, we have our solid the way it was. By dragging this, what it does, it's like you are moving back, you are suppressing everything. Anything that is below here, it's not visible, it's suppressed. If you drag it back, you drag it again, you have it back. So that is it for this video. For those who have not subscribed to the channel, I'd like you to subscribe so that you get more of these tips and tricks, so that you don't miss anything that I update or I upload, because I've decided to make videos like this to assist the new users to Inventor. Not only Inventor, AutoCAD, Revit, Fusion 360, I will be making videos like this to get you started. And then there's no product which is better than any other. It's how good you are in that product, and then what you intend to do. What's your intent? For instance, if let's say you are building a structure, you have to use a different tool like Revit. For that, we will be looking at Revit tutorials later on in this channel. So I want you to subscribe and hit the notification bell. Hit the notification bell so that you don't miss these videos. Yeah, thank you so much for watching. Share the videos with your friends, the links, so that they can come learn with us. Thank you very much.